Okay, so we're back. We will start building our buildings now. So let's drop in a geometry node. And let's name it city source. So obviously this terrain network was quite small, but this is how big is the city network. It starts like this, tiny nodes, a lot of loops, Pythons. So that's why this part is gonna take a few chapters, but that's, I promise you, it's a lot of fun. Once you start seeing the results, it's really satisfying. So let's start by bringing in our environment. So we'll drop an object merge here. Actually, when I was making this tutorial, when I was preparing the video, first I actually used the actual layout to create my variations, only then to actually put them in the world origin to rescatter. So, but that's what we're gonna exactly follow, and because there's actually there was a good outcome out of it. So what we want to bring is now our environment. So just go into this object. I think I just do that all the time by default. So I'm gonna lock this. I'm gonna go into the terrain, and I'm gonna bring in the one with the pikes. So if I activate this, it's gonna load my geo. And then we're gonna just hide everything else, I suppose. It's gonna speed up things. Come on. Oh, slow. Okay, maybe this is slowing it down. I'm just gonna switch so we don't see numbers. Okay, maybe it's because I have two Houdinis open and I'm recording a video. So I guess, yeah, that's fine. Okay, so for this scatter purpose, actually we don't need a high res. So this is something that we could actually do it right, I suppose. But yeah, I guess it's fine. So now what I want to be able to do is that I want to use these pillars as the center of my buildings, okay? So then I need to isolate these parts. And what is the most common geometric feature here is those flat sides, right? So we can take advantage of that using normals to isolate those sections. And that's exactly how I did it. So I created a normal swap, switch to couldn't be vertices, is fine. And I created the normals that are gonna be there. This is taking a while. It's a heavy geo. Okay, let's switch to here. Then I'm going to group. Actually, I think I should really make that proxy version, because this is gonna take a time. And we don't want that. Let me see. I actually don't have the proxy version. Oh, okay. So, well, I guess we're stuck with this then. Okay, well, we're gonna use what we have. Okay, so drop in a group swap, plug it in. It's gonna just create the group now, but we want it based on normals. So that's coming now. So the yellows are selected, right? So I want, just gonna put this to manual before I push it. So I want on y-axis to be 1, and then spread angle to be 74.6. So that was like a trial and error to get the, and then changes to points to get the correct section. So that's gonna give me everything else but those sections pretty much. Just let it cook. Okay, so as you guys can see, it's like pretty much giving me all the flat surfaces, and there's some contamination, but that's fine. So then we're gonna put a blast, and we're gonna blast group 1 away. So that's gonna be group 1. Excuse me. And I'll plug that. And now I'm gonna have my nice area that we're gonna use for scattering, which is gonna blast now. It's taking a while. Okay, obviously we have some dodgy geometry, so we're gonna put another clean soap under this just to get rid of some of those holes. Okay, so I guess something must have changed because I wasn't getting these edges. So okay, we can hand clean them too. It's pretty straightforward. It's a city after all. Environment won't change much. Okay, maybe we should. Yeah, I'm going to do a lasso and just go around. Oh, actually we want some of those as well, so it's gonna be a little bit more tedious. Okay, can I do that? Yeah, I can. Okay, I don't want that. That. Continue, almost there. Yeah, because we want some buildings stuck on the edge. There. Keep going. Keep going. Well, if we change the environment, we have to do the same thing again, so let's not change it. Okay, so yeah, it's a lot better now. That's good. Okay, what do we have here? Then I have an attribute wrangle because I want to scatter points, but I want to be able to control where I scatter the points. So I'm going to just remove the color now, so I can see it a bit. Like I don't need that color here. This is attribute delete. I should take care of that. Attribute delete. CD. Just want to get rid of the origin. No one. Okay. Cool. Now let's put a point. Whoop. And we're gonna name this scatter density. And dive inside. So what I want is a relative bounding box. Okay, well, there's some more stuff that we can clean. Let's do that. We can do something like this and then reverse it maybe. There's some really far geometry, so I don't want them. And then maybe reverse. Okay. Okay. Sorry about that. Okay, so scatter density. So what I need is that I want to be able to tell, I want to create a ramp that I can shift around based on Y. So I'm gonna drop in a relative bounding box. And then what I need is the Y component. So I will plug in, I'll bring in vector to float, so that returns. So what we can do, actually we can observe it like this. If I plug this into the CD, it's gonna give me a ramp, right? So it's like, this is literally the Y height of each. the relative height of the point on y-axis. So if I go like that, it's gonna give me something similar to. Now I want to be able to ramp this, so let's change it. So this is 0 to 1 already. So if I go ramp, ramp parameter, so let's bring this back in, just drop it in there, and this is gonna give us a color, but what we want is something called dense, so density of, so tab bind export, and I'm gonna call it density. Okay, like this. So now we have a new attribute called density. Oh, that's not a vector. Well, because it comes as a vector, and because we didn't convert it, if we don't overwrite, it does. As you can see, it comes as, but we don't want. That's 3 times the data we don't need. Okay, and we don't need the color as well. So now we have a way. Well, now we need to visualize it. Let's put a visualizer. Let's say density. It doesn't show up here. Density. Ramped attribute. Grayscale. So now if I move this guy up and down. I can play now with my scatter. So just pick the black one. So just I don't want really low buildings. That's why we're doing this, and change its value to, I guess, 0.2. Okay, and now we can put a scatter node. This value will define the density and the variation of an individual building. So my current value is 6,000, and I don't need that. Okay, so now we're gonna go down and do a little cleanup on these points, which is everything. And then I'm going to create a little node called, well, actually I think maybe I should, yeah, well, that's fine. Attribute randomize to create a little scale variation, and our first crash of the day. I didn't even touch anything. Hopefully it's all good. Let's get the file. See, that was one of those things. It's. I mean, it does leave a window open that it crashed, this and that, but it's a bit more easier and clear here. And then we can check why it crashed as well. See what it says. Well, I should probably make a ticket, but yeah, well, not today. Okay. Alright, so let's open our crashed file, which I think I also, because it crashes often, yeah, this should be here. There it is. Hopefully it's good, so we don't have to go back and do it again. Okay, very good. So let's save our file to our project. So that's still the environment, pretty much. Well, let's call it to buildings. I'm sure it's going to be more than one part, so let's call this part 1. Okay, are we still recording? Because I am talking. Yes, we are still healthily recording. There's the other recording software, is synchronizer, read audio samples, warning, received audio samples with none. Okay, that's fine. So we want to randomize our point scale. Just let it do its thing because we didn't bake it. It's doing the whole geometry thing again. Yeah, maybe it's time. Okay, we don't want to repeat that. So the points don't take space, so we can actually use stash in our scene, but that will affect our scene size. But I mean, if you look here, this is like nothing. So let's put a stash. So at least after this, because if you put it here, it's gonna be more, because there's a lot of geo, there's a lot of data here, and even here actually after we clean it up. So that's probably a good section. So that's like baked scatter. Okay, so if we need to scatter again, then we do it here, and then you press stash. So next time, if you're visualizing this, anything under these parts will not cook. Okay, so that's gonna help us. So we want to randomize the scale. So P scale is for, so I guess we can do a little test here to show you what I mean. And then I'm just gonna, I guess, just do it by hand. No, actually, let's not do it by hand. Just gonna go here, say 0, delete non-selected. So it's gonna give me 1 point somewhere. Copy to point, right? So require primitive copy the points. So P scale by default makes this attribute rangle. Let's say F at P. I think we don't even need that should also work. Equals 10. Okay, so it became 10 times bigger. But we're using this one because it's a bit easier, just to randomize it. But if I say scale, I don't know if we need to say vector because it's an internal, but I guess we don't have to yet. Because if it's not a custom attribute, if it's a Houdini reserved attribute, you don't need to declare its type. So then I can say, like it's still gonna do the same thing. But what if I say 1, 10, 1, 110? Okay, well, 5, 50. And that's how you randomize. That's how you can scale an object with different values instead of like uniformly scaling it. So let's go back to our point cloud. We set attribute randomize. So these are the values that I use. So they're gonna come handy. 2, 1, 2, 4, 11, 4, and it's a scale. And we can continue from here. Now we're gonna drop another point WAP. Okay, I want to export 2 variables again. I think we can copy the one above, but now let's just do it again. So I don't need this yet. So WAP, point WAP. So I'm using again in here relative bounding box to store, because I want to reset the why am I doing this here? That's a bit strange. I need to, what's the purpose of this? Why am I okay, I guess we're gonna find out. Vector to float. So I want this time to output. Oh, okay, that makes sense. No, yes. So bind export, which we could fetch them, but I guess I probably use it somewhere. Okay, so I don't think we need to create that, but I don't know why. Well, I did it anyway, so let's just do it. So I create 2 point attributes. Pretty much bake the. I mean, we could have, because the reason I'm saying I'm not sure why is because we can actually get that value with a wrangle. So I don't know why I'm creating extra data here, but I guess it was maybe it's for test. So now the other part we're gonna do is that now what I want is to be able to create some little clusters. So cluster points. I guess this is the part that I use it for variations. So like if you just plug in, it's just gonna give you like little clusters, but we need our values first. So it's like 50. Okay. Refinement iterations 50. Okay, so that's what I'm doing. I'm using these threshold attributes. So that's why I'm using them. And it's supposed to create me where is it? Cluster points, colored points. Okay, and I have a threshold of, what is this, gold threshold 3.07, but it's not really changing. Maybe this didn't work. Is it? The cluster values are not changing correct now. So I'll leave it there. Maybe I change it somewhere else. Let's go to averaging settings. They are as default. And okay, so now we have some clusters which we are going to use for creating the building shapes. And then I have one more point up under. Some of these I may not be using. I'm just going to copy paste this. Actually, let's give this a good name. Let's say this one is scale randomize. This one is for bake bounds. This one is pretty straightforward. So in point WOP 2, we're gonna now copy paste this. So let's just delete that. Let's bring in the cluster attribute that we have here. And now using that, I'm gonna generate a random value. So I'm gonna drop in a random node. Just plug this guy here. This is an integer. So we need to change its type to integer. So this is now gonna generate a random number. So if you just plug it just for observation, for every unique cluster value, it gives us a random value. Okay, and then I want to fit this random value from 0 to 1 to 0 to 4. Okay, and I'm gonna use that value for point export eventually somewhere, which is for it's just that. Okay, so then, okay, I see. I want to create a value for each. So I'm gonna actually hide everything else so we can see it a bit better. So we have cluster, right? And I'm using that, we created a random value, which was the color, like we could see. So that's like, but it's still 0 to 1. So I am kind of like kicking it off to all the way to 0 to 4, and then I will put this back. Okay, so then let's view shape. So then I created like 0 to 4, right? And then I just pretty much export as an integer. So I just get rounded numbers. Okay, and then I'll use that for copying types. Okay, so let's go back here. Now is the copying part. So what are we copying to this build? These blocks, right? These are our, like, we're gonna copy something to them that kind of resembles like a building. So the way I thought would be interesting was to start with a box, and this box is uniformly scaled to 10. It's a polygon mesh, and axis division is 444. So where is it here? It's just a box. Okay, so then I made a little tube. So let's pick a tube. This tube is a polygon. It is actually quite low res, just 4 and columns 6. And it has closed caps. And I think that's it. This doesn't have anything else, but I wanted to have the shape and size of this box. Okay, so just plug that guy in there. So then I made another one. But this time it's 4 to 24, so it's a bit round. And then I made another one. this is the same one, but I kind of like put a transform here. So I want to create like scale 2.6. Okay, uniform scale, and these are just random numbers. I just want to do a boolean pretty much, just to create a bit more interesting shape. So then just this goes right here, this goes right there. But that's not what I want. I want to subtract from A to B, so that's what I have. Cool. Did I change anything else to make sure that I don't skip? Yeah, that's fine. Okay, and then just drop in a normal swap for all of these to have these hard edges. Okay, so drop the vertices cusp angle to 10. So I have one here. So that's my other building block. That's my other building block. And my box is my other building block. So it's kind of like we're gonna play Lego now. So let's put a switch. And let's just plug them here. Now that's gonna go into our copy section. So that's we should probably organize this slightly better. It's not a mess. And let's call these building blocks. Okay, now we're gonna create a for each loop to do our copying. I guess we're gonna use for each point. So this goes in there. We put a copy to point. This is gonna go not like this. It's gonna be a null, and I'm gonna explain you why. So let's rename this point to copy. CPY, and then this goes here, and then this goes there actually. And in the switch, we need some information. So like here, we pull in 1 point, and we have some information here. We're gonna drive the switch with the shape attribute. So just like how do we call a point attribute from an expression? So it's called a point expression. If you want, you can just do a little reading on it, how it works. It's fairly straightforward. Actually, if you go like point, it shows up what it needs to be doing, and then you go open parentheses, double quote, the address of the data you're after, the geometry, let's say, and then you go like, I want to look at, then we need to put a comma. So the second one is, sorry, it's the, I didn't close the, here, comma. So then we can keep reading. So returns the x component of 0.3. So the number 3 here in the example section is the point number. Since we are always fetching only 1 point at a time, that's going to be 0 for us. 0. Now I want to fetch the attribute name. As you can see, it's declared as a string in double quote. So our attribute is called shape. And if this was a vector, or we could have fetched the third one or the first one, so it's not. So that's should return a number, hopefully. And yes, so because we have the scale attribute here already, don't we? We do, right? Yes. So we just did a one copy. It just used by using the shape, which we can visualize here because our clusters. So each one of these is gonna get a mixed bag of these guys, pretty much. So let me see, and so I just run it. It's just gonna copy it. Okay, we can. We should be able to compile, I guess. I mean, it's quite fast. That's not really necessary. We will get to the compiling a lot later down the line. Okay, so these are our building blocks. What can we change if we don't like basically this means like here I'm gonna have one type of building, here I'm gonna have mixed type of buildings, here I'm gonna have boxes. So then what if I want a bit more boxes and cylinders and then a bit more interesting? These are just basically, this is just going to define the silhouette, so it's not that important. But if you have a bit more interesting shapes, that's where you're going to do it, at the building blocks. If you want a bit more mixed bag of design in your buildings, remember this is a sci-fi, it's a completely futuristic, you just want more clusters. Then so if I get 100, you're just going to get a bit more variety in the single section. Okay, if I want 200, they're just gonna get more mixed up. Let's go 500. Let's see what's gonna be like. It's just probably gonna divide a lot more. Yeah, so that's actually pretty interesting. We might as well just go with this. I think I will. I mean, yeah, it's neat. I don't know. Okay, well, let's stick to what we're doing, so it doesn't become very different. So what was our original value? 50. Okay, let's check the recording time. That's 30 minutes. That's fine. Okay, so now we are ready to process and create our details section of our buildings. So now I have a little section here called section prep. So that's what we're gonna do. It starts with an attribute delete. And the reason I occasionally do this is because I don't want, it's better not to have what you don't need and then try to figure out why it's not working down the line because you forgot an attribute somewhere and you cannot figure out what's going on. So it's easier like this. Just clean it. If you need it, you'll remember, you'll go back, you'll bring it in. Otherwise, for something that you might be searching that you don't understand where it's come from. So like if you forget the scale down the line, it's going to affect a lot of attributes and it might be confusing. So now I want to promote my attribute cluster as a primitive. Attribute promote. So from point to primitive using first match. So we just brought it here. Why I did that is because I want to pack each one of these sections. Oh, there you go. It breaks sometimes. It's the viewport. It's fine. Let's close it up. And now it has to load the other one. Okay, let's just hide what we don't need. So because I have a cluster and I have 4 clusters, so using the clusters I want to create a packing system. In order for that to work, I need to promote it to a primitive, but then packing works with strings, so I'm gonna convert this attribute to a string. Cluster ID. Some of these might be a bit too old school. Sometimes people tell me, "Are you doing it this way?" Because there is a new way to do it, and I'm like, okay, but yeah, still works. So in code, you write your string cluster, then you can say plus integer to array, then you bring in the attribute. I add cluster. And this, because our attribute cluster is in primitive, so that's kind of gonna give you the new string. And then we can pack these. With cluster ID. Cluster ID. then it's going to give us 50 packed objects instead of individual polygons or whatever. So now we can process each one of these based on the cluster ID, which is going to make our life a bit more easier. So then I want to sort these primitives by X on X axis, because I don't know, it's like, where is it? Why it's not updating? Spreadsheet is broken. Geometry spreadsheet. Okay, so just drop in a sort node, and the reason that is because I think it was a bit difficult to remove and add buildings later on, so I just want to sort them so I can use, maybe create some kind of because my camera was, I think, at the x-axis. Sort, that's it. Okay, so that's for side effects. Linux, latest NVIDIA drivers, that's not working. It's causing issues. Okay, did I transfer? I think when I pack, I probably shouldn't have moved. Yeah, we should keep the cluster ID. Okay. Okay, and then I'm gonna drop another attribute wrangle. So let's give this a name as well. Let's say, so we remember after, integer to string x. Okay, little example there if you need it. Then let's put another attribute wrangle. This is not necessary, it's already correct. Oh, no, it's not. Okay, oh, yes, okay, so we've figured out why you're sorting it. Because I wanted to get the cluster numbers sorted on x-axis. So I sort them, then in here, I'm gonna say, because they're packed objects now, I can use the prim numbers to renumber them, so it's not going to be a problem. So I can say now my new cluster ID I would like to have is equal to cluster underscore close parentheses low quote integer to array again, but this time use primitive number. And run over primitives. Yes. Okay. So now my point number matches my object, and now if I delete anything, it's gonna follow the x-axis. So it just gives a bit more control, because like when I want to process them, I want them to process like, you know, sequentially instead of just getting picked up randomly. So we don't want that. Like I said, a little bit OCD, so it helps. All right, so that's our prep section. So let's give, and let's maybe say, let's put a null here. Let's say sections, cluster sections, cluster sections. Okay, how long is it been again? Been 40 minutes. That's fine. We can do 20 more and then stop and then go. So we're gonna give this, what can we say here? We can say scatter prep. Actually, I want this to be scatter prep. So it goes up here. Let's put on manual, just organization is everything, guys. Let's just say another null here, scatter geo, scatter geo. Let's just give it a nice color. Okay, and then this is our scatter section, so that's different as well. Scatter PTC points. That's our copy section. So let's go there. Copy blocks. And then this is our building prep. Building prep. Okay. And then this can stay like this for now. All right, so now it's all organized, so we're gonna process this information. So what do we do next is then we start working on each cluster individually. So what I want to do now is first well, okay, so it starts like that, and then we'll go to PDG part after. Okay, so then what I want is first I want to create a blast. Well, actually I'm not using a blast here, I'm using a wrangle, so let's do this the wrangle way. So I want to create a little wrangle to isolate what I want to process. Okay, so let's call this split models, and I will put this on auto so I can see what I'm doing. I at ID equals at primnum. Okay, which probably I can do the same thing here. It's literally the primnum, so why not do that? Let's do that. It's a bit easier there. Let's just less node, because that's the same thing. Yeah, okay. Then using a slider in the primnum, I want to delete what I don't want, and that's how we're gonna organize the wedging process. That's gonna go into PDG. So then what do I say? I can say if integer ID is not equal, I'm not typing, sorry, if integer ID is not equal to this parameter that is an integer also. That's important how you write CH, CHF, CHV, because that's how it's gonna populate the wrangle when we press this button. So because I want this to return an integer, so then I want it to be named, I named it missile ID, very strange, building ID. Okay, in quotes, building ID. So I have to remember when I have to link it back in. So then 1 parenthesis for the string, 2 parentheses for the condition. Then what to do? Remove prim. Since they're packed, it's gonna remove the whole thing instead of a few primitives. And from yourself, using primnum, and get rid of the points as well. So if I go like that, now I can use this to move it around, okay? I think there's a way to adjust this automatically as well, but I actually don't know. I'm sure it's easy. So let's call this was the split models, yes. Split models, okay. So all nice and dandy. And now what I want to do is bring each one of these in a world center, because that's why we want to create our buildings, just to avoid, I don't know, further issues with transformations or baked values, because we want to instance them. So you want to instance them in the world center. Otherwise, otherwise you need to compensate from the original position, which is a bit more complex. So in order to do that, we just need to put a transform. this was the prep, right? So now it's all clear. So we're gonna go, actually I think we should bring this here. Oh, get out. This should be another section. Yeah, that was the prep section. Now this is the making section. Okay, so split models, cluster sections, transform. So we're gonna just type, I'm sure there's an easier way for this, but I've been doing it just the same way forever. So I guess I should improve my workflow a bit more. So $CEX minus $CEX minus $CEY. That's sometimes when they give when side effects give you so much control, you just end up making your own way. And then in the pivot transform, copy expression. Oh no, relative. No. But why is not copying all of them? Copy, paste. Okay, it doesn't. So I got like paste. Okay, we'll just type it, just this time without the minus. Okay, $CEY, $CEZ. So now our building is in the road center exactly. Okay, so now we can actually unpack it, so we can work on the polygons. As we unpack it, we don't need anything yet to be coming in. So the first step is to save. It's been a while, so we should save. And I think, yeah, we can continue. So it's going to be buildings part 1 still. All right. So we did unpack, so we have the geometry now, and we're going to call in geo. So we will start to render list. I have another thing here that I'm doing, but I think I should also, oh yes, because we need the that's for the rendering part though. Where is it coming from? After the sections, I have the split model. This needs to be more correct. That's the packed part, so it's here. So this needs to go there. Is it? Oh, I'm confused now. I confuse myself. That goes sort, and then after the sort we had the cluster ID, then we have the sections. After the sort we had sections. Okay, yes, after the sections. Okay, so these are split models is after. So what am I doing here? Delete non-selected size. Oh, that was for okay. We'll get there, because I created a little section that just I can move a bounding box around just for doing the tests, but that we will make it if needed. We don't need it right now. Okay, so back to what we were doing. Maybe pick a different model. I don't know. Yeah, it doesn't matter. So we saved anyway. And the reason I said is because we're gonna introduce the boolean now, and then sometimes it becomes finicky. So let's put a boolean, because what we don't want is all this stuff inside. What we want is the shell. So if I go to another box, because there's a lot of box over a box over a box, so that's not gonna work. So but if you put a boolean and then set it to intersect, and then I'm just gonna undo this one, because it was kind of like sometimes giving undesirable results, and then let it run super quick, and now we have an empty interior, so we can build our floors. And our shape is pretty cool. It's broken up. I think we could also like create wires and stuff, but I guess we'll do it as we go. Okay, so then we will start by creating our floors. So what I need first is a line. Maybe we can give this a name as well. because that's the section. Well, I actually also have to shape this a bit better, because it's gonna look very different, and then I'm gonna struggle myself to find what I'm doing. So I am going to take all these as another box, so it just looks very similar to what I'm doing. Okay, so basically what we did so far was this. So, oh boy, that's gonna be a long tutorial. So then, which is good, of course. I'm gonna move this guy towards the left. Okay, a little box around as well. Okay, so from here under we'll go for floors again. So I want to start with a line, and I want to get the centroid and the bounding box. Basically, I want a line that is starting from the bottom to the top, that is straight, right in the center. So I'm gonna write a few expressions. Let's rename this to remove inside also. So I want a few expressions, right? I want to write here centroid. Let's move the mouse. Double quote. We're gonna go to ingeo, centroid of this. So I want a centroid of x and z, and the bounding box size as well of the base. And then for the length of the line, we're gonna use the bounding box size. So centroid ingeo, okay, comma d underscore x. Okay, that's gonna give you the x centroid. Okay, well, did I write it correct? I am not sure. Let me see. I did. Yes, correct. Is it correct? It's correct. So copy this and then go to the last one. Z. Okay, and then we want to get the base position, the bounding box y minimum by just typing this again. Go to ingeo, comma d. It explains here dy max, dz max, you know. So d underscore y minimum. And that should give 157, which should be equal to this as well. There's 2 points here. What is it? 2 points. What was our number? 100 minus, yeah, okay, so that's pretty much that. So we got the value. Now we need to learn about the length. So that is another expression that we can use called bbox. Using the bbox is the dy size. So actually I just can probably copy that just to change the last part. So dy size. Okay, so now we should have a line that is as big as that and right in the center. Okay, that's working. Now, why I did this, this I have to figure this out as well. Okay, that's a tricky one. Oh, that's because I'm using the floor calculator. Right, okay. And this is using 2.5, then that's the height. Okay, so now we're gonna define our floor gap, like how much distance we want the floors to have. So what I need is now under here to drop, so this is, I'm gonna drop a wop swap, point wop, so this guy goes there. and then I'm gonna bring my unpacked geo into the second input. Am I even using this actually? I'm not. Okay, so I don't need to bring it in. Sorry. Well, I think that's a big problem with big tutorials. You do get lost in your own scenes, interestingly. Okay, so then what I want is I need a fit in here. I don't think I'm using this because I need to resample this before. Or oh no, it returns. Yeah, I use it because it returns the detail attribute. So the other thing is that this needs to run on detail level. Detail. Okay. So go inside. So it returns the information here. So let's go back inside. We put a fit. So I want to put a mix as well. I'm gonna explain now why. A mix. So mix goes into value, and we're gonna promote input 1, input 2, and input 1 will be source max. So src max. So that's our, like, I guess, the biggest floor we want to have. I don't know, 5 meters, 10 meters, whatever. And then this is going to be src min. So that's like, don't make anything less than this, because then you need really small people. Source min. Okay, so then I have a constant, which is my total height, right? Which we already found here. So then we can basically promote bias. Okay, and we will call it height, total height, which is this guy. Copy, paste. So what did I, for me, I think I did 2.5 to 5, and then dive inside. Then I want to fit this in a value that, so I know my minimum value, which is my source minimum. So source minimum is, because I want to fit this in a value now. And then I want my destination. So where is this going? 1 second, source min, it then is source max. Okay, so where's my source max? So I know my max value as well, which is gonna go here. I just want to export this because it comes, I want to be able to see the numbers. Bind. So it's gonna give us an average value for our floor gap. Okay, so right now 0, of course. Just need a bit more space here. Okay, so my, what, that's destination max. So my source min goes to my destination max, destination min goes to my source max. Is this correct? Source max, yes, is it? Yes, I think so. The wire is a little bit confusing. And then I took this value, so it's giving me 2.5. So why is it giving me 2.5? Because I'm just passing it pretty much the same way. Just put a divide after. I should have, I think, rehearsed is a bit better. Where is my constant? So that goes there. And then I'm clamping it. Sorry, that's the wrong order. It's this here and then this here. Okay, so that's 126, and then I'm clamp. 3 to 5. Well, I guess I was trying to automate that and probably did it very complicated, so we should probably just put 5 there by hand. Okay, that's I think one of the things that I probably just made it and then just ditched it. Okay, so let's right after this point warp, I called it height. I even have a little Python code here. I'm not even sure what I'm doing. Height 222.6. Oh, because I was just calculating the height in Python instead of bbox, I guess. That's strange. Okay, so height. Then we're gonna put a resample because now we need more points. And that's coming from our detail attribute. So I'm just gonna, the length is coming from our detail attribute, which is 5. So I put a 5 here. So it's like, okay, I copy pasted that. I shouldn't have done that. So just like we used in other places, like point attributes here, in order to fetch a detail attribute, because now floor gap is a detail attribute. That's what we need to type in the length section. So detail /, height, because that's the name of our node, comma, floor gap, comma 0. That should return 5, and it didn't. It did a little mistake somewhere up there. Okay, typo. Okay, so if I middle click here, I have 2 points. If I middle click here, I have 65 points. So it's gonna give us 65 floors, because that's the height divided by 5. There is no other attribute I am exporting from here, no. And then I'm putting a little attribute wrangle. To remove points, but with a little condition. So I say if at point number is equal to endpoint is the total number of points. So if it's gonna error here, but now it's gonna return me 65. Okay, so if I say, actually let me show that before. So like let's say at foo equals endpoints 0, so that's gonna return you 65 because we have 65 points. So now I'll bring back the expression I was writing. If at point number is equal to endpoints -1, remove point. So basically I'm just trying to remove a point that is at the end of the line. So we can visualize that once we have the correct. Okay, so it's 0 to 64. So then let me finish this expression so it doesn't error. Remove point 0 at pt none. Okay, so it removed 64. It's like, so no matter how many floors there is, I always remove the last floor. And the reason I want to remove the last floor is because it's at the top of the building and I already have a cover from the building itself. So we're just generating floors. So there's no floor on the ceiling pretty much. So that's what we're doing here. Okay, so then next thing is to create a floor, which is a grid. And because we are making really big buildings, everything needs to be super optimized. And we just need something slightly bigger. So we need to make sure that it is always bigger than this. So we're gonna do a little expression again. It's all expressions everywhere. So we want to get the bounding box size of InGeo, close it, comma, d underscore size, and we want it slightly bigger. Did I write it wrong? InGeo, no, that's correct. Why is it erroring? bbox InGeo slash times 1.1. Why is it erroring? Isn't it these InGeo? InGeo underscore. Oh yes, sorry, there's a Z here. Okay, just copy this, paste it here, and say X size. Oh, I think this they need to be other way around. X Z. Okay, and so it's 1.1 times bigger, so it's slightly bigger, and then make sure that we have enough coverage. That's important now is that have UVs, because that's our floor, and if you do thickness, it's a different story which we'll add after. But you need to have UVs, and the reason we are adding UVs before we extrude it is because it's almost like, well, it's a bit of a cheat, but it's if we have overlapping UVs, we can use one baked map to do the both side of shading once we extrude it. If you want to do it right, you need to extrude it and then create the UVs properly. So let's get UV texture. I think I actually create UVs at the end, to be fair. No, because I just lay them out. Yes, we keep them. That's fine. So orthographic y-axis, that's fine. So now we're going to do copied points. Floors, points. Okay, so we have our floors and we have our build, but this is not correct because it was correct here. Why is it rotating? Doesn't matter, we can rotate this guy. Okay, so now we have our building encapsulated by the floors, except the last floor because we did remove it. So now we're gonna do a Boolean operation. We're gonna save our scene as well. Once we have the floors, we're gonna stop the video. We'll continue with the other details. So now this is the shape we are interested, but we don't want shatter. What we want is, so first of all, that's important. So the left side is a solid, right side is not, so it's a surface. And then I again want intersect all polygons. These sometimes cause problem. I remove them if you get weird shapes. But now we have our floors that fits in. That's pretty cool. Like that's where we need the normals to be fixed as well. So now actually we should continue that and probably add back, because I never had straight edges in my buildings, and I mean initially my initial ones were, and then I figured out that was not very eye pleasing. So I actually bring in another Boolean operation here, which we will later on, to do a bit more interesting shapes, which I call external wall prep section. So right now we're gonna skip that. We're gonna put a null to remind us. So this is like cut floors, and this is gonna be like cut edges, but it's a placeholder. So like if say, hey, what is this null doing here? It's like if it's not cutting any edges. So then I want to measure the area as well, because I'm going to use it. So I go measure swap. Okay, we're measuring the area. Okay, so it gives me the attribute here. Then I'm gonna put an attribute wrangle, and I'm just gonna remove, like I say, the huge, the really small areas. If I have like really, because you know, because each one of these floors, it might end up in a really, because it's a procedural nature of it, and we're really creating this out of like boxes and shapes. So I just want to make sure that if I have something that's really small, I don't want it to be a floor. So, and then I can say if at area is less than 200, remove prim 0 and prim none, and remove the points as well. On primitives. Okay, so it may not have changed here, but if I'm pretty sure if we keep changing these guys, so let's also, maybe it's a good time before we stop the video to stress test our current progress. So we have this guy, right? We need to, well, I mean, we have only a few more nodes, so let's switch them as well. So now I want to do an extrusion, poly extrude, and my floor height is, I decided that it will be 0.5, and we want to up it back as well, so we have a little floor system happening here. We call it extrude floor. So now I'm gonna create a group, because these are my floors, which are gonna be called floors. Okay, and because my normals are reversed, I'm gonna reverse you. Or maybe I should just, well, yeah, because I do a negative here, I should probably do a positive and create normals maybe here, because that's breaking it. Let's try. So I'm kind of fixing it along the way as I go. So right now normals are fine, and now they're fine, so I don't have to reverse anything. So now it's pretty good time to actually create an attribute for the material system, and I'm gonna use this time another way to create an attribute is attribute create, which is literally the same as what we are doing, like this. But why not? And we'll kind of call it ID floor. Super important, so we can make sure that we can assign materials after without a hassle. Material, I'm gonna turn on the local variable on. It's a primitive, it's a string, and it's called $os, which is ID floor. Okay, so now I have an ID floor here. That's cool. I did transform these up because why? Because I went down. Okay, so I guess I did transform this up as much as I extruded. So then I'm gonna do the opposite. So I'm gonna bring it down minus 0.5 meter. Okay, now a little bit attribute cleanup. If there's anything like this, is probably, I don't need to create the normals anymore. I have my normals. I have CD. I don't want CD. Attribute delete. I don't want that to contaminate my shaders accidentally. Okay, I don't think we need these two anymore as well. Well, if we do, we're gonna bring them back. Shape, I don't need shape as well. So this one is gonna be a bit more optimized. I don't need, I don't need color. I don't need this guy. I don't need, do I need any of these? Cluster, no, because we are gonna copy the cluster ID anyway, so I don't really need those as well. Pretty much just the material and area. Okay, so I have the material, I don't have the area anymore. If we need it, we'll come back. So the last thing I did was the UV layout, because we're gonna bake textures, so we need to lay out our UVs. So UV layout, I'm gonna save this again. Oh, should I pause? I should have paused the other scene. Sorry guys, just hitting the escape many times so I can actually see the attributes. Okay, I'm gonna put this on manual before I actually let it go. So here are the settings. By default, okay, so actually let's run it maybe. We saved it, right? Because I want to see how it processes. So by default, it's gonna do this job, which is fine, but every floor, and this is just super tight, and we can never have enough resolution with this. So what we want to do is play with some settings, right? So I want to scale islands to match the surface areas, because I don't want one floor, two floors are the same size to have different quality settings. And I want to have the, where is this, pack islands in cavities in other islands, that's on. Spread islands to all available spaces as well. And under the advanced, I want to run 2 iterations, so it just kind of like does it a bit better. And change it to 2K. It takes a bit more time now. You can keep it at 1K. It's just trying to be more accurate, I guess. Okay, and so now we want to pack them into UDIM tiles. So I'm gonna pack this to change it to manual, and I'm gonna go UDIM tiles, and I want 4x4 UDIMs. About 4x1, sorry, 4x1, 1 column, starting from 1001. Okay, and then I go auto update, and now it's gonna spread our UVs so we can actually bake them with a bit more high resolution. Okay, since we're gonna use it, well, that's not very ideal, but it's gonna do the job, because we're gonna bake. We're not really using displacement or anything in these renders. So okay, so now I guess the last thing is now to say null out floor, give it a color. Go, and then the last thing we're gonna check now is, but we're gonna check it from here because I don't want it to slow us down. And then we're gonna see the rest of our geo, and then save and change the building to see if it successfully generates other floors, and just by using the slider, and it works. It's cool. So we have floors, any type of building. It's gonna give us floors, no matter what, in the world center. Okay. Now some of them are awfully fast, so some of them are a bit floaty. Okay, so we're gonna finish this video, and we will continue creating our procedural buildings in the next one. So I'm gonna save the file here, stop the video. This was a long one. Okay, thank you.